So we are going to discuss about atoms and all. So first of all, we are going to study about atomic models. Atomic models. The first scientist that give a model of atom is J.J. Thomson. So atomic model is given by the first model is given by Thomson's. So I'm going to write a topic Thomson's model of atom. Thomson's model of an atom in 1904. He said that atoms are like watermelons and the electrons are like the seeds in watermelons that are distributed uniformly all over the watermelon. And it also says that the mass of atom is uniformly distributed all over the atom. So first I'm going to write it. Thomson was first write with me. This part is basically theoretical, so you have to write. Thomson was first to propose a detailed model of that, a detailed model of atom. What he says is that atom consists of uniform sphere, uniform sphere, positive charge, uniform sphere with a positive charge in which electrons are distributed uniformly, in which electrons are distributed uniformly. Next point about Thomson's model we can write. This model is also known as this model is also known as plum pudding model. Plum pudding model. And the next point, or it's also called watermelon model. Watermelon model. Because he compared this atomic model to watermelon. Watermelon is just the difference is that the atom is spherical in shape, and this sphere is positively charged, in which electrons are distributed in the same way that the seeds in watermelon are distributed. And he also says that the mass of atoms are uniformly distributed, which were not true. That's why it was one of the drawbacks from atomic models. And he also doesn't say anything about the movement of electron. That means Thomson's model was a static model, a static model. So this was also one of the drawbacks. So what is Thomson's model? He says that atom consists of a uniform sphere with a positive charge in which electrons are distributed uniformly. And this model is basically known as plum pudding model. Please write it. And then you will write a topic drawback. Drawbacks are very important. Why it failed? What is the drawbacks of this? And I think you have studied about this in class 9th also. Let me know, Maha and Arnav, whenever you are done with this.
I'm done, sir.
Arnav,
Yes, sir. Done.
okay. So what is the drawback of this? I already told you the two drawbacks. The first drawback is the mass of atom is considered the mass of atom is considered to be uniformly distributed, uniformly distributed, because the mass of atom is concentrated Am I audible to all of you? I was just
Yes, sir.
disconnected.
Yes,
Okay,
sir.
sorry. Now see, what I wanted to say is it is a static model that he doesn't tell anything about the movement of electron. A static model, that means at rest. That means it doesn't reflect movement of electron, movement of electron. Next, the drawback is it couldn't explain the stability of atom. It doesn't say anything about the stability of atom, so it couldn't explain the stability of atom. So please write all these three points which are very important. Let me know when you are done with this.
Done, sir.
Very good. Arnav,
Done, sir.
okay. Now the next model comes up. Rutherford's experiment is alpha particle experiment. Second model of atom is Rutherford's scattering experiment. So basically, Rutherford does an experiment that is known as alpha particle scattering experiment. So what is this experiment? There is an atom in which there is nucleus, this nucleus, and he started alpha rays, bombarding of alpha particles. So he saw that most of the alpha particles passes from atoms without deviation. Most of the alpha particles passes from atoms, inside atoms, from atoms without any deviation. Very less alpha particles are deflected by small angles, and very less alpha particles is very less alpha particles, 1 in 20,000 alpha, 1 in 20,000 alpha particles retrace its path. That tells us that something is in center of this atom. That what we call that tells us something is in center of this atom that later discovered as nucleus. So what does this Rutherford a scattering particle is? So basically alpha particles bombarded on gold foil, and he saw that most of the particles passes through this atom and very less particles deflected with a very small angle, and one of 20,000 particles, 1 in 20,000 particles retraces its path. That suggests us that something heavy is in center of atom, that is called nucleus. Is that clear? Is that
Yes, sir.
clear? Now see, Rutherford's observation during this experiment, Rutherford's observation. So basically, what is the observation of Rutherford? Most of the alpha particles, you can write with me, most of the alpha particles passed through the gold foil undeflected, passed through the gold foil undeflected without deflection. Second observation is that we can write a small fraction of alpha particles were deflected by sorry, I was just disconnected. Am I audible to both of you?
Yes, sir.
Okay, thank you. So second observation is that a small fraction of alpha particles were deflected by small angles, that I already told you. Third observation is that a very few particles, 1 in 20,000, you can write 1 in 20,000, bounced back. That means it traces its path, bounced back nearly 180 degrees. At nearly 180 degrees. Please write it.
Done, sir.
Done, Arnav.
Just a minute, sir.
Okay. Maha, do you
Yes, sir.
need backup class of first chapter? We can have backup class of first chapter in another time. We will arrange some time.
No, it's okay, sir.
It's okay?
Yeah, it's okay.
Okay then.
Done, sir.
Very good. Now see, conclusion. What is the conclusion from this experiment? is very important. To see what is the conclusion. Most of the space in atom, most of the space in atom is empty or vacant or vacant. Next conclusion is that atom has positively charged particles, and which is concentrated in the center, which is concentrated in the center in a very small region, in a very small region called nucleus. We call it nucleus. And this nucleus is very heavy and dense. So this was the second observation. Please write it. And you know that in nucleus, proton plus neutron reside here, which is also known as nucleons. That means particles in nucleus. And outside nucleus, there is electron. Please write it.
Done.
Very good, Maha. Now,
Just a minute.
okay, no problem. Take your time.
Done.
Very good. Now see, Rutherford also tells us that basically radius of atom, or sorry, radius of nucleus is the radius of nucleus is proportional to the cube root of the number of nucleons within it. Cube roots of the number of nucleons within it. And you already know that nucleons, that means n plus p. Neutron plus proton is mass number. Yes or no? I have already taught this. So radius of nucleus is directly proportional to mass number raised to the power 1 by 3 cube root. And to remove this proportionality sign, we need a constant, that is R naught, proportionality constant in this. And R naught has a value that is 1.33 into 10 raised to the power 13 centimeter. A is what? N plus P. Please write it.
Done, sir.
Done, everyone?
Yes, sir.
Very good. Now we will study about drawback of Rutherford. Drawbacks of Rutherford atom. What is the experiment? Drawback of Rutherford's experiment, or you can only write drawback of what? This alpha particle escape. So the first drawback, it didn't tell anything about the stability. So I'm going to write the first one. It could not explain the stability. Stability of atom. Okay, one more point you are going to write here is that conclusion is that electrons revolve around the nucleus. Around the nucleus. He also says that electrons revolve around the nucleus in a fixed orbit. Okay. So first drawback is that it couldn't explain the stability of atom. Please write this both point. This is not drawback. This is point from Rutherford's atom. Next, it could not explain. It could not explain the electronic. It could not explain the electronic structure. It could not explain this electronic structure. Third point we can write. It could not explain the energy. It could not explain the energy of electron in different orbits. In different orbits. Different orbits have different energies. Okay, so please write all these points. So first drawback is that nothing about the stability of atom, electronic structure, and then could not explain the energy of electron in different orbits. Please write. Electronic structure, that means basically electronic configuration. How many electrons will reside in first cell, second cell, third cell? That is electronic structure.
Done, sir.
Very good. Arnav?
Done, sir.
Very good. Now see, Rutherford says that this is nucleus, this is basically the cells. If electron continuously moving, if you are walking continuously or running continuously, you will lose energy. Yes or no? Yes or no? Arnav, Maha, if you will walk continuously, you will lose energy in
Yes,
the
sir.
same way. If
Yes, sir.
electrons will revolve around the nucleus, it will continuously lose energy. And always remember from now that if electrons are far away from nucleus, it will have more energy. That means the first shell electrons will have lesser energy than the second shell electron, and the third shell electron will have more energy than second shell electron. The farthest from nucleus you are going, the energy will increase. Are you getting my point?
Yes, sir.
So the first point is that if electrons will lose energy by since it is continuously moving, it will come to second energy level because it has lower energy. Then again it is moving, it will lose energy and it will come to the first shell. Again it is moving, and after losing all of energy, electron will go and collide with nucleus, which is very unstable for an atom. So he also doesn't explain about this. If electron will continuously move, then it will lose energy, and if it will lose energy, a time will come when it will fall into the nucleus, which is not possible. So it is also one of the drawback of Rutherford's model. Is that clear?
Yes, sir.
Very good. So both of you done with this?
Yes, sir.
Yes, sir.
Okay. Wait a minute. So I already taught both of you about wave nature. Maha,
Yes, sir.
wave nature, wavelength and all. I didn't finish all that, right?
Yes, sir. You explained that.
Okay. I'll do it now. The radius of nucleus. We need to find the radius of nucleus, L13, and here it is 27 will be. Please solve this question. Any answer? Should I explain?
Sir, is it 3.99 into 10 raised to 13?
3.99 into 10 raised to the power 13. Now, so we had a formula that R is equal to R naught A raised to the power 1 by 3. A is what? Mass number. R naught has a value 1.33 into 10 raised to the power minus 13 into what is the value of this? 27 raised to the power 1 by 3. So we can easily calculate this. This is simple maths. This is basically in centimeter. And we can write 3 raised to the power 3. And already we had a power 1 by 3. So 3 3 is a 9, 3 3 is a 9. So 3.99 into 10 raised to the power minus 13 centimeter. Radius of nucleus of aluminum. Arnav,
Yes, sir.
are you done with this?
Yes, sir.
Very good. So now I'm going to give you some important questions. So please try to solve it. The question is, first question is, an element with mass number 81 having 31.7% more neutron, having 31.7% more neutron than proton, Write the symbol of element. Very easy question. If you are not able to solve it, just let me know. If you can solve it, just do it.
So can you solve this?
Yes, I can. So the question is very easy. You can say it's more mathematics than chemistry, but the concept of chemistry will also be used. Okay. Now see an element with mass number 81. Mass number is given as 81 and having 31.7% more neutron than proton. That means let number of proton be x. Let the number of proton be x. Wait a minute. Is it something going on? Okay. Number of proton be x. Then number of neutron, you can see number of neutron will be equal to, you know that according to the this statement, neutron is 31.7% more than proton. Whatever is the proton, it will be 31.7% of proton, it will be more. So I'm just going to find calculate this 31.7 upon 100 into x. So number of neutron, we will get number of neutron again will be equal to, if you are going to take LCM, you can take LCM 100 and then x 100x plus 31 point, so it will be 131.7x. Is that clear up to this? Yes or no?
Yes, sir.
Yes, sir.
Now you also know that mass number is equals to given as 81, and you know the formula from chemistry. A is equal to n plus p. A is equal to n plus p. You already know about it. A is equal to n plus p. And what is A? That is mass number 81. What is neutron? 131.7 upon 100. And what is proton? Number of proton? X. Can't you calculate the number of X? Please calculate number of X. Sorry, calculate the value of X. Should I slide it up? Maha? Arna? Please calculate the value of
Sir, is it 79.68?
No. The value of x?
Yes.
No, it won't be.
Sir, it's 3.5.
No. So I'm going to teach you how to calculate, how to do simple maths. So you are going to take first. This is basically X here. I just forgot to write. Did you uh, use this or not? Because I forgot to write this value. Can you solve it again or not?
Yes, sir.
Okay, please do it. It's very easy.
Sir, is it 78.68?
The value of X?
Sir, it's 35.
Yes, it is. It is 35 point something. If you're going to take LCM, it will be 100, and then 131.7x, then 100x. It will be 81. Now again, you can see it will be 8100 if you are going to cross multiply it, and it will be 231.7x. So the value of x will be equal to 8100 upon 231.7. So if you are going to divide it, it will be almost 35 point something. Basically 34.9 something, which will be almost equals to 35. That means any element that has atomic number, proton is equal to atomic number, and mass number is 81. And you know, with atomic number 35, it is bromine. Are you getting my point? And you can easily calculate number of neutrons now. You just need to put the value of x here and you can calculate it easily. Maha,
Yes, sir.
then please write it. Let me know when you are done with this.
Done, sir.
Ma, you are also done, right?
Yes, sir.
Okay. Now going to give you another question. An ion with a mass number 56 and 3 units positive charge. Positive charge, that means if any element has positive charge, what does that means?
Number of electrons is less than number of protons.
That means it loses electrons. That's good. Number of electrons is lesser than, if positive charge, than proton and 3 units positive charge, that means 3 electron already lost. Okay. Now the question, it contains 30.4% more neutron than electron. 30%, 4%, 30.4% more electron than electron. Write the symbol of ion. Write the symbol of ion. Please do it. I am waiting. And if you are unable to solve it, just let me know. Done. Can you do this?
Just the last step.
Okay, waiting for your answer.
Sir, 22.62. Oh, wait.
22
One
point?
second, sir. 1 second, sir.
No, you made a mistake. Maha, can you do this?
Yes, sir, I'm doing.
Okay, so we need to calculate.
Sir, iron.
Yes,
Fe
iron.
symbol.
20, what is the atomic number?
So 26.
What is the mass number? 56.
So
That is
56.
given. That is given. And plus 3 positive sign. Maha, what about you?
Sir, I didn't get it.
You didn't get it?
Yes, sir.
No problem. See, Maha, do as question says. So it contains 30.4% more neutron than electron and 3 unit positive charge. So I'm just going to take let number of proton be x. If number of proton is x, then number of electron in neutral atom should be x. But here in this it is ion which has 3 positive charge. That's why the number of electron will be decreased and it will be x minus 3. Is that clear?
Yes, sir.
Now number of neutrons will be equal to this x minus 3 plus 30.4% more neutron than electron. That means 30.4% of electron x minus 3. You just need to solve this. Okay, when we will solve it, you will get something like this 130.4 upon 100 into x minus 3, I think. Yes or no? It will be like this. Yes. This is number of neutrons. Now we need to calculate mass number. So that we can easily represent. So mass number, it is given that mass number is 56. Mass number is 56. And we know that n plus p will be equal to 56. Number of neutron we just calculated is 130.4 upon 100 into x minus 3 plus number of proton, that is x, we had taken, suppose, is equal to 56. So you can easily calculate x from here. Is that clear, Maha?
Yes, sir.
Please write it. Are you done with this?
Yes, sir.
Okay, I'm going to give you a homework question. So the question is, an ion with mass number 37 and 1 unit negative charge. It contains 11.1% more neutron than electron. Write the symbol. Please write this question. We will study in the next class about cathode rays, discovery of neutron, nucleus, and all that. So please, this part is theoretical. At least read from NCERT and whatever books you have. Please read it. and on coming Thursday we will have test. Every week there will be a test. Okay, Arnav, are you done with this?
And no suggestion.
Okay. Maha, are you done?
Yes, sir.
Okay. Thank you for today then. Arnav, you are also done with this?
So just last line.
Okay.